All right, welcome to the Explainer. Today, we're going to tackle one of Java's most fundamental, and let's be honest, sometimes frustrating, data structures, the array. So here's the plan. We're going to kick things off with the basics, then dive right into the 5 most common traps that catch everyone out. From there, we'll get into the why, like why are arrays so rigid? We'll check out some more flexible alternatives and see why your choice here can make or break your app's performance. And of course, we'll wrap it all up with the key takeaways you can start using right away. Okay, first things first. Let's build our foundation. What is an array in Java, really? And why is it such a big deal in the language? The secret is right here in the definition. 2 things should jump out at you: fixed number and single type. That's it. That's the whole game right there. It's the core trade-off of an array. It's super fast because it's simple, but that same simplicity is what makes it so inflexible. Okay, theory's great, but let's see what this looks like in actual code. So first up, we declare an integer array. Looks simple, right? Int array numbers. Then we give it some life, initializing it with 5 values like 10, 20, 30, and so on. Now here's the part that gets people. To get that first element, that 10, we use numbers of 0. Always 0. That means the last number, 50, is at index 4, not 5. You have to burn that into your brain because it trips up so many developers. All right, now that we've got the basics down, let's get into the fun stuff. The common traps. Seriously, these catch everyone, from brand new coders to seasoned pros. Knowing what they are is half the battle. The classic off by 1 error. This is probably the #1 mistake people make with arrays. Look, if you have an array with 3 items, your valid spots are 0, 1, and 2. That's it. The second you try to ask for what's at index 3, bam, your program just dies with that infamous array index out of bounds exception. We've all been there, and we're going to make sure you don't have to be. And this right here, this is usually what causes that off by 1 error. Because arrays start at 0, that last valid spot is always length -1. So your loop condition has to be I less than array.length. If you use less than or equal to, you are absolutely 100% guaranteeing a crash on that last loop. It's just a recipe for disaster. Okay, this next one is super important. People think you can resize an array, but you can't. Not really. When you make a new, bigger array with the same name, you're not stretching the old one. You're throwing the old one away and creating a brand new one. All your old data, gone. Poof. Unless you manually copy it over. So remember, it's not a resize, it's a replacement. Now this is a tricky one. Java lets you create an array of object and just toss whatever you want in there. A number, some text, you name it. But just because you can doesn't mean you should. This is chaos. It totally defeats the purpose of Java's strong type system. It makes your code a mess, forcing you to constantly check what kind of thing you're pulling out. And yeah, it can really slow things down. Seriously, this is trap number 5. If you're still writing old school for loops with an index counter just to go through an array, you're making your life harder. Use the enhanced for loop, or the for each loop. Instead of all that for int I equals 0 business, you just write for int number colon numbers. It's so much cleaner, way easier to read, and the best part, it makes those off by 1 errors literally impossible because you're not touching the index at all. Okay, so after seeing all these traps, the fixed size, the picky typing, the constant threat of runtime errors, you kind of have to ask, right? Why? Why on earth were arrays designed to be so rigid? And the answer isn't that it's a bad design. It's actually a really clever design for its time. It's all about a specific set of trade-offs that were made way back in the 90s, before a lot of the fancy features we have in Java today, like generics, even existed. This gets to the absolute heart of the issue. Back in the day, an array of strings could be treated like an array of objects. They called this covariance. It sounds flexible, but man, was it dangerous. You could try to stuff an integer into your string array, and the compiler would just shrug. The whole thing would only blow up when you actually ran the program. Fast forward to modern Java and its collections, they use something called invariance. A list of strings is a list of strings, period. You can't pretend it's a list of objects. It feels more rigid, but it's so much safer because the compiler catches your mistake before you can even run the code. So, okay, if the old school, rigid, fixed-sized array is the problem, what's the solution? What do we use now when we need a list of things that can actually grow and shrink? Well, meet the Java Collections framework. And your new best friend within that framework is the ArrayList. Just think of it as a super smart, flexible array. You can create an array list for your strings and then just use simple methods like .add and .remove. The array list handles all the messy resizing stuff under the hood for you. No more creating new arrays and copying data. It just works. But wait, it's not quite that simple. It's not just about picking arrays versus collections. Even within the world of collections, the specific type you choose can have a huge impact on performance, especially when you start dealing with a lot of data. Take a look at this chart. It's comparing how fast different data structures are at doing their thing. Now, when we're only working with 1,000 items, which sounds like a lot, but in computing it's pretty small, you can see that most of them perform pretty similarly. That green bar, the standard Java collections, it's right there in the mix. The differences are tiny, almost unnoticeable. But now, watch what happens when we jump to 1 million items. Whoa, the story completely changes. Look at that gap. Some of these optimized choices are just light years faster. And this is why a decision that feels totally insignificant on a small project can suddenly become a massive performance bottleneck in a real-world application. Understanding how things scale is everything. All right, we've been through the traps, the history, the modern solutions. So what's the bottom line? What do you absolutely need to remember the next time you sit down to write some Java? Okay, here it is, your cheat sheet for working with arrays in Java. Number 1, always check your bounds. Just be mindful of that zero index. Number 2, use the for each loop whenever you can. It's cleaner, it's safer, just do it. 3, if you have a list that needs to change size, just stop. Don't fight with a plain array, just use an array list. And finally, number 4, when you use collections, always use generics to lock in that type safety. That's it. Follow those and you'll save yourself a world of headaches. You know, the whole story of the Java array teaches us a really important lesson that goes way beyond just Java. Every single tool we use as programmers comes with trade-offs. The original array chose raw speed and simplicity over safety. Modern tools like ArrayList lean more towards safety and flexibility, and they pay a tiny performance price for it. So the next time you reach for a data structure, don't just ask, what does this do? Ask yourself, what was the trade-off here? Figuring that out, that's what separates a good developer from a great one.